had plenty of problems that we've dealt with, but nothing is more doable, in my opinion, than inequalities. In terms of when you have tried them out before, it's possible that you might get some right, maybe some wrong, but the biggest thing is understanding the reason why. And so this is one of those classes where it's going to be very understandable to understand what went wrong and to get those points the next time you go take your test. So we obviously have a game plan today, and we want to make sure that I ease you into this. The last thing I want to do is throw 500 problems your way before you have a chance to understand the nuances here. So here's today's game plan, my party people. Number one, we're going to be recognizing and interpreting those four main inequality symbols. So just before I started this recording, I went over some of them where we have greater than, less than, greater than or equal to, less than or equal to. And those are the symbols that we'll be working with today. Now, no need to take notes right now. We're going to move forward in a couple of moments to take our actual notes, but these are the symbols that we'll be working on today. So if you're feeling like that's something that gave you trouble in the past, then this is going to be a really good class for you specifically. So that's game plan number one, really understanding those four main inequality symbols. Now, number two, this is something that I brought up again right before the recording, and I want to confirm with you again. So my party people, who here has had trouble in the past understanding when and why to flip the inequality symbol? For example, having something like x is greater than 3 turn into something like x is less than something. Who here has had that issue understanding when and why to flip that symbol? Right on. Yeah, and again, one of those main issues that so many people needlessly suffer through. But in today's class, we're going to have a really good look in terms of when and why to take that action. I got you, my party people, and the right way to do it. So only after we get through those fundamental pieces, like understanding the four main inequality symbols, and then beyond that, knowing when to flip the inequality, then we're going to get into that practice. So we're going to get into that practice, and we're going to solve both single and multi-step inequalities. This is a two-part series. So today's part one. Tomorrow we will be going through part two. So if you understand today's game plan, really understanding the nuances, those terms, and getting plenty of practice, type in the chat box, got it, and we'll move on to our main notes, page one. Right on. And this sounds like a great class today. You guys are really on it. I'm really excited to teach you all. So let's go ahead and start taking our notes here. So our main notes here, this is page 1 of 3. And we will go ahead and go through these notes in just about a minute and a half. So my party people, let me go ahead and put the timer here on the screen. And I'm going to give us, again, a minute and a half. I'll give us 2 full minutes to go ahead and take these notes down. Actually, here you go. A minute 35 should be appropriate. Once you're done writing these notes down, just type ready in the chat box, and we'll be right back. All right, my party people. And that is time for the first page of notes. So, my party people, let's go ahead and go through this. Again, without being rushed, let's go ahead and go through these notes one by one. So, let's get the timer out of the way. And here we go. So, first things first. Again, like we said, we're starting off with those inequality symbols, and we want to understand them. So, we have the greater than symbol right there. And again, like I said, it means greater than. So let's go over some of the ways that these are going to be properly used, okay? So number one, let's take a look at this example here, and let's say, hey, 5 is greater than 3. That is an appropriate way to use it because 5 is indeed greater than 3. Now, I want to go ahead and do this next small little example. It's going to be pretty obvious. I know it's going to be pretty obvious to the vast majority of us here, but it's going to be very important to understand those nuances, those really, I would call finer details when it comes to dealing with inequalities. So everybody, let's take a look at the second one that I'm going to write down. If I wrote down 5 is greater than 5, my party people, is that true? Is 5 greater than 5? Correct. Absolutely not. 5 is equal to 5. Yeah, it's equal. I'll give you that all day. But it is not greater than itself. 5 is not greater than 5. And that's going to take us into the conversation into these two in a moment here. So just hold that thought and let's keep it going down this line here. So this line over here, we have less than, and we're going to write that down right over here. Let me just cross this out. And let's say 2 is less than 3. Again, that is a factual statement. 2 is indeed less than 3. Now, if we were to write something that is incorrect or false, here's an example of that. If I were to write, let's say 7 is less than 4. Everybody, is 7 less than 4? Right, it's not. It is not. There's no day of the week where that's true. That is false. Not true. So this is just a nice warm-up with these inequality symbols. Now, we've talked about less than and greater than, and I'm hoping that there's some intuitive sense that's being made here. But now I really want to focus our attention to these two right here. The greater than or equal to symbol and the less than or equal to symbol. Everybody, can you just point out, what do you see with your eyes? What's the difference between these first two symbols and these two symbols over here? What would you say if you were just to kind of explain it simply? What would you say the difference is for you? Yeah, the line underneath the symbol, right? Exactly. The line underneath the symbol, that's really what brings in the or equal to. That's what brings that in. Now, I want to go ahead and show an example of what this looks like and how things are going to be, again, just slightly different. So let's go ahead and ask ourselves the same questions that we have before. Everybody, is 5 greater than or equal to 3, in your opinion? Correct? Yeah, that is true. It is true. 5 is greater than or equal to 3. Now, let me explain this just a little more, because again, the nuance is so important, and I really want to solidify what you believe you understand. Everybody, when we think about the symbol greater than or equal to, it can be greater than or it can be equal to. If either one of these is true, then it's all true. So, for example, everybody, is 5 greater than 3? Yeah, it absolutely is. 5 is absolutely greater than 3. On the flip side, is 5 equal to 3? It is not. That is true as well. However, what was the statement? The statement is 5 is greater than or it's equal to 3. One of those is true. It is greater than. So yes, this is indeed true. It's greater than or equal to. If one of the two are the case, then you're good to go. My party people, does that make a little more sense? Again, the greater than or equal to, the word or is very important here to make that distinction. And on the flip side, well, let me actually give you another example where it could be incorrect. So let's go ahead and say we are taking a look at 5 is greater than or equal to 7. Let's take a look at that. My party people, let's break it up into two parts. We'll first ask ourselves, is 5 greater than 7? And then, is 5 equal to 7? In both cases, my party people, I think we can all agree, 5 is not greater than 7, and it's not equal to 7. So this statement would be false entirely. So notice how, since they were both false, hey, it's false automatically. When you're using that or, so greater than or equal to, less than or equal to, if one of those is true, then you're good. So let me go with that example that I showed earlier. Here's the last one. We're going to write 5 is greater than or equal to 5. Let's try this out real quick. Everybody help me out. Is 5 greater than itself? Is 5 greater than 5? No, 5 is not greater than 5, right? It is not bigger than itself. However, my party people, the word or, is 5 equal to 5? Yeah, 5 is equal to itself. Yes, it is. And so we can check that off, therefore making the entire thing true. So are we starting to see where the word or is a very important word to know when it comes to understanding inequalities? Good. Very good. And so again, we're going to take this fundamental understanding and really expand upon it, practice with it. We'll do everything we can with this. But I really wanted to start off by showing you just different examples of these symbols in action. That way you understand what these things mean. So again, take a last second here, take a screenshot if you need to. But we're about to move on into page 2 of 3 of your notes. So one more time, if it's pointing to the right, it means the left side is bigger than the right side. If it's pointing to the left, it means the left side is smaller than the right side. And so with that, if we have that line underneath, that means or equal to. So greater than or equal to, and less than or equal to. Again, we'll talk more about this as time goes on. But are we ready to move forward here? Sweet. Sounds good. Let's go ahead and push it over here to page 2 of 3. So here's where inequalities are going to seem a little familiar. Who here has solved an equation before? Not an inequality, but an equation. So like x plus 1 equals 8, or things like 2x minus 3 equals 17, stuff like that. Are we familiar with that? Do we recognize just regular old equations? Awesome. Sounds good. Here's the great thing about inequalities. You solve them the same way. You solve them the same way. You do order of operations, but backwards to figure out what that little variable is going to be. So that's something that we can really, sigh of relief. We can really give that sigh of relief because the process for solving inequalities and equations is pretty much 99% the same. The only difference right here at the bottom, it's when you multiply or divide both sides by a negative. Whenever that happens, and I'm going to be very specific here, everybody pay attention. This is very important. When you multiply or divide both sides by a negative, let me highlight this here, by a negative. Let me change that color so it's very clear that I'm really pointing that out. When you're dividing or multiplying both sides by a negative, you will then flip the direction of the inequality. You will flip the direction of the inequality. So for example, if you're using the greater than symbol and you multiply both sides by a negative, well, then it switches to less than. Now, I'm going to give us, like I did before, a minute and a half for you to take these notes, and then I'm going to show you some examples to prove to you that this actually is true and it will be true. So that way you have that understanding and you're not sitting here memorizing things and hoping for the best. So I'm going to put the timer up one more time. I'm going to give you 1 minute, 30 seconds here to take these notes. And again, we'll come back nice and relaxed to try some examples out. All right, in a few more moments here, about 10 seconds. All righty. And so let's go ahead and really understand this, because again, the last thing we want to do is for me to tell you what to do without you understanding why you're going to do it. So just really quickly in the chat box, who's been there before where you were told what to do, you didn't understand why you were doing it, but you still did it anyway. You went along with it. But then the next time it came to doing it, that idea, that thought of, well, why the heck does this work? Why is this the way it is? And then slowly your confidence starts going down and down and down. And then next thing you know, you got to relearn everything all over again. Yeah, we've been there before. So this is going to help us not go through those moments again. I know how frustrating it can be. I've been teaching for over 10 years. I understand. I definitely understand. But I got you. So everybody, let's go ahead and take it back to the same example that we had earlier. Let's go ahead and say we are looking at, let me use this space over here. Let's say we're saying 5 is greater than 3. Just to make sure, everybody, just to make sure. Is that true? 5 is greater than indeed, right? 5 is greater than 3, indeed. Cool. Sounds good. And if we don't believe me, allow me to go ahead and make a little number line over here. And I'll put a 0 right there. And I'll just do a +1, +2, +3, +4, +5. And then I'll go negative as well. -1, -2, -3, -4, -5. So let me go ahead and just write these out. 1, 2, 3, 4, and 5. And then we have -1, -2, -3, -4, and -5. So my party people, let's go ahead and check this out. So we had, let's say this is 5 in purple. And then we had, let's go ahead and use green for the 3. Okay, so let's go ahead and give it a shot here. Excuse me one moment. There we go, wanted the pen. All right, so everybody, we have 5 over here. And then we have 3 over there for sure. 5 is for sure greater than 3. It's more to the right. Now, what did I say? Oh, if we just so happen to multiply both sides by a negative or divide both sides by a negative, this thing right there, that inequality, we gotta flip it. So let's see what happens if we make both sides negative, but don't actually flip it. Let's see if that's actually true. Let's see if that's still gonna be true. So if I put a negative with both, let's use a slightly different color. Let's use gray here. If I tagged a -5, then -3, and then I kept the same symbol, everybody, let's check it out. -5, that's right over here, correct? Yes or no? Yep, that is where -5 is, right? So let me go ahead and take this over here. Let's move it all the way over there. Perfect. Now, my party people, if I made the 3 negative, that's -3. So give me a yes or a no. That would be right over here, right? Sweet. Sounds good. So, question. Is that going to be true then? Is -5 greater than -3? No, it's not, right? Like over here, 5 is to the right of 3. So yeah, 5 is bigger than 3 for sure. But when you flip the signs, now -5 is less than -3. Look at that. Look at that. That's a little interesting. And that's why, notice that how when we flip the signs of both sides, or for example, multiplying and dividing by a negative, because again, that's how you flip the signs of the sides. When you flip the signs of both sides, you must flip the inequality symbol. You must. That's the biggest key there. Because when you flip what you're comparing, you flip the relationship. When you flip what you're comparing, you flip the relationship. That's what's happening. So I really want us to understand these nuances. And trust me, I know that it might not be like second nature right from the very beginning. And that's what the practice is going to be for. But I really want to make sure that these ideas here make sense before we get into that practice. Do y'all understand what I'm saying? Making sure that we get the nuances, the ideas here now before we start, kicking ourselves with all these problems. Good. So that's one of the main things that we have to understand. If you flip the relationship, again, multiply by negatives on both sides. If you flip the relationship, you flip the sign, and that's it. Now, I want to follow up on that. I want to segue that because there's one thing that I just said, right? I said, if you flip the relationship, what happens if you flip the sides? Does that also flip the relationship? Let's see. Let's find out. And we'll work with negative Shaletta in a moment. I got you. Now, let's go ahead and see what happens if we don't make both sides negative. What happens if we just swap the sides? Like, what happens with that? So let me go ahead and show you here. Let's pretend that let's say we have 1 is less than 3. Again, something very understandable and true. 1 is indeed less than 3. I hope we can all agree on that. Now, what happens if we flip or swap the sides? What if I move the 1 over here and move the 3 over here? What happens if I just switch them? Okay, let's see. I got 3 over here. I got 1 over here. I'm going to keep the symbol the same. Question, everybody. Is 3 less than 1? Right, correct. No, 3 is not less than 1. So that's why that rule exists. If you flip or if you swap the sides, you also swap the relationship. You also swap the relationship to keep it true. Exactly, Jonathan. You have two situations where you flip the inequality symbol. Number one is when you multiply or divide both sides by a negative. That's number one. Number two, if you swap the sides. If you make the left side the right side the left side, you also flip the inequality symbol. Again, two situations. Number one, when you multiply and divide by a negative. Number two, when you swap the sides. My party people, does that make sense to you for now before we get into the practice? Yeah, again, those are the two situations. Exactly, Dayana. We swap the sign to make it true. Exactly. Dante, to answer your question, so in every situation, do you always change the sign? Not always. You have to let the problem kind of show you what you need to do. I'm just letting you know that if those things are needed to be done, like multiplying, dividing both sides by a negative, or flipping or swapping the sides, those are the situations that you would be flipping the direction of the inequality. Yeah, those are the situations. But it won't always happen. It might happen in some problems, might happen in others. So you have to keep a good eye out to make sure you know when you're applying these rules. So with that, I had someone ask me, can we try this out with negatives? Is it still true if we do negatives? And my answer to that is yes. Let me go ahead and show you. Allow me to move this off to the side, maybe make it a little smaller over there. Let me take away those markers I had for where the numbers were. And let's go ahead and use one positive number and one negative. Everybody, let's go ahead and say that we are going to say here, -3 is less than, let's say, 2. Everybody, is that true? Is -3 less than 2? Do you see how -3 is to the left of 2? Right. Absolutely. Now, let's see what happens if we do both of those things. On one hand, we will multiply or divide by a negative on both sides. And in another situation, we'll just swap the sides. And let's see if these rules hold true. So number one, let's multiply both sides here. Let's multiply both sides by -2. Let's try that out. So everybody, if I multiply by -2 on both sides, everybody help me out. What's a -3 times a -2? What's a negative times a negative again? A -3 times a -2? Yeah, that'll be positive. A negative times a negative. Remember, that's going to be a positive. I got you. And then what's 3 times 2 going to be? Correct. +6. Again, multiplication, everybody. Multiplication. 3 times 2 is 6. And a negative times a negative. Yeah, that's going to be a positive. So we have a +6 here. And then let's check out the right side. Let's do 2 times -2. Everybody, 2 times 2, that's going to be 4. I think we can all kind of skip that part. But what's a positive times a negative? What's that going to give us? If the signs are opposite, it always ends up as a what? Yeah, always ends up as a negative. A positive times a negative, that's going to be negative. So we have -4. So this is how it kind of changes things. We go from it being -3 is less than 2. Now what we have is, let me actually just use 2 different colors here to make things easy. Let me go ahead and use, right over here, let's use green for this side, and then let's use blue for this side. So this is where my blue was, right over here. And then this is where my -3 was. So after we did our stuff, we have a 6 now. So I'm going to move this over here to where the 6 possibly would be. And then at the same time, this 2 is now -4. So let's go ahead and move that over here to -4. My party people, do we notice that after we multiply by a negative on both sides, the relationship switches? This is no longer true. It is no longer true that 6 is less than -4. That's not true. Notice 6 is way bigger than -4. 6 is way bigger than -4. Exactly. So because we multiply by that negative on both sides, we have got to take this symbol right over here. We have got to turn it around. And so I'll go ahead and swap it around. Let me just get rid of it right there, actually. There we go. And we will flip it so it shows greater. So before I go to the same idea, but just flipping the sides, does that make sense, my party people? Whenever you multiply or divide, hear me clearly, multiply or divide both sides by a negative, that's when you flip the symbol. Excellent. Now, lastly here, now if we were to, again, now swap the sides out, let me get rid of all this here on the right side, goodbye. So I'm going to start with the same exact problem. We have -3 is less than 2. Now, what happens if we flip the sides, if we swap the sides? If I move that -3 over here, and then I move that 2 over here, what happens? So we have 2 here and -3. Everybody, if we thought about it, we have the -3 and the 2. Now, my party people, think about it. What's the relationship? Well, 2 is bigger than -3. 2 is to the right side. So notice When we swap the sides, we have to flip this so it's pointing in the right direction. Because yes, -3 is less than 2. Here's -3, there's 2. Yeah, it's less. But if I were to flip it and talk about the 2 first, then we would have to say that the 2 is bigger than -3. We're saying the same thing. We're saying the same thing. -3 is less than 2, and 2 is greater than -3. Notice how it's just about which way you're saying it. Is this starting to make a slightly more sense than it did before we get into the practice? Sweet. And again, I know some of y'all are really itching to get into those practice problems. I totally get it. I know we're going to have fun, but it's even more important to really get that quality over quantity. So many of us are used to just working problem by problem by problem, but then we get into that, that pickle of not understanding what those mistakes were. That's what this is all about. So I'm going to zoom on out here. I'm going to go over the notes. I'll let you go ahead and screenshot this one more time. But remember, with solving inequalities, we're going to treat this just like equations. You can add or subtract the same number from both sides without changing anything about the inequality. It's only when you multiply or divide by a negative, that's the only situation, aside from swapping the sides, that you flip the symbol. Again, 2 things: multiplying or dividing by a negative, or outright swapping the sides. Those are the only 2 situations where we flip the symbol. If you understand that and you have your notes screenshotted or taken down, type "got it" in the chat box and move forward to the last page and then get straight into that practice. Good. All right, here we go. And 3, 2, and 1. So last one here. So this is just kind of like a standardized testing deal here. So basically, when you are solving these and you get your final answer, when it comes to equations, we typically have like x equals whatever. Let's say x equals 2. You can say x equals 2 and you can say 2 equals x. Both of those really are correct. They mean the same thing. But when we deal with standardized tests, typically, what do we notice? Typically, we see that the answer choices A, B, C, D, whatever, you typically have your x on the left side. Typically. Who here has noticed that to be true? Typically, when you're writing the answers to equations or otherwise, you typically notice the variable is first, then that equal sign. Right? Cool. So you're likely going to run into the same deal here. So whenever we are dealing with problems on the actual test and you're looking at those answer choices for inequalities, we want to get into the mode of knowing how to write the variable on the left. We want to get into that mode. And that's how today will go. We'll have all of the variables on the left. So it's going to be very important to understand if we get our final answer looking like this. Check this out. If we have our final answer looking like, hey, 3 is less than x. Go ahead in the chat box, everybody. I'll give you 20. I'll give you 10. I'll give you 10 to 20 seconds. Go ahead and write what this would look like if we had x on the left. Go ahead, give it your best shot. 15 seconds left. And 3, 2, 1. Go ahead. Let me know in the chat box. What do we have? Okay. I see a couple of us with the right answer there. All right, so let's go ahead. Let's go through our notes again, everybody. If we flip or if we swap those sides, so if I put x on the left and 3 on the right, what needs to happen to that inequality symbol again, everybody? What needs to happen? Yeah, we got to flip it. So it'll go less than, it'll change to greater than. Again, if you swap the sides, you flip the symbol. Because if you swap the sides, you're swapping the relationship. Here, 3 is less than x. That's the same thing as saying x is greater than 3. X is greater than 3. So again, if we swap the sides, you flip the symbol. All I did here was take that 3, put it on the right side, the x, put it on the left. And so the less than turns into greater than. And I'll go ahead and show you what that means with regular old numbers. So as a reminder here, let's go ahead and take a look at this. Everybody, right over here, we can confidently say that 7 is less than 8, right? We can confidently say that. Now, what happens if we swap that? If I, instead of writing 7 less than 8, what if I wrote 8 first and then the 7 second? What if I swapped them? If I did that, 8 over here, 7 over there. Everybody, what's the proper way to write the relationship of 8 versus 7? 8 is, 8's bigger than 7 for sure. So notice what happened. We turned it from this to this. That's all that means. If you swap the sides, you just have to flip the symbol. That's all I'm saying. I know it's a little tougher to see with variables because you don't really know what x is, so it might be a little confusing. I totally get that. But when we use regular numbers, my party people, is that idea reinforced? Is that idea making a little more sense? If I swap the sides, 7 less than 8, if I start off with the 8, then the 7, we got to flip the symbol because 8 is bigger than 7. Right on. And for sure, I know that it'll take some practice, but remember, that's what we're here for. We're here to really get this down, to really, truly understand this. That is correct, Catherine. So Catherine's question was, okay, so when we swap the sides, we flip the symbol regardless if we had multiplying and dividing negative numbers. Exactly. Regardless of whatever the heck is going on. If you swap the sides, you flip the symbol no matter what. No matter what. And those are two separate things. Like the multiplying, dividing by a negative versus swapping the sides. Those are just two circumstances, two situations in which you would flip the symbol. So great question, Catherine. I see that a lot of folks appreciate you asking that. Thank you, thank you. So with that said, my party people, let me zoom on out one more time to let you go ahead and take a screenshot of those. Now, with that said, are we ready to get to our example problems? Sweet. Sounds good. So here's what we're going to do. We have 2 pages of examples. So we have number 1 coming up right over here, and then we'll do example page 2. All we're going to be doing here, we're going to keep it relaxed. We're going to keep it nice and easy, but we're going to go through solving these inequalities, which means getting x by itself. And keep in mind, everybody put your pencils down. Keep in mind, if we need to use one of these specific rules that we learned, we'll use it. My party people, is it safe to assume that we're always going to be using one of these rules? Is it safe to assume that we'll always be using them and just using the rules whether you see things used or not? Correct. That is not safe. That's not a proper thing to do. We can't assume that we're going to be using certain ideas. And that's why today, like I said, it's going to be really, really focusing on those nuances. So follow along with me. I got you. And at the end of this page, I'll zoom on out and let you take a screenshot. I got your back, everybody. Let's take a look at number 1. Here we have x plus 4 is greater than 10. Everybody, do we already have the x by itself? Is it already alone? Or do we have to do stuff here to solve this? Right, it's not by itself yet. Because if you notice, it's x plus 4 is greater than 10. I don't want x plus 4. I just want x. So remember, everybody, this is just like solving equations. And even if you didn't have all the practice in the world on solving equations, don't worry. I got your back. It's all about working backwards. You may have heard me say that before if you've seen me teach equations before. So, everybody, the operation that we see is adding 4. My party people, what's the opposite of adding 4? Yeah, it's going to be subtracting. Now, just like with the equations, do we just subtract 4 over here, Or where are we subtracting for? Oh yeah, both sides. And I'm going to repeat that a ton today. Both sides. So if we're subtracting 4 on the left side, we got to subtract 4 on the right side over there. And once we do that, everybody, what's going to happen over here when we add 4 and subtract 4? Angelique, appreciate y'all. Yeah, we're going to cancel out. Yeah, cross that thing right out. And that's going to leave us with just x. Now, question, everybody. Question. Am I flipping the symbol here? Am I flipping the symbol? I see a lot of no's, a couple of yeses, a lot more no's. All right, so the answer is going to be no. We do not flip the symbol in this circumstance because, let's check our notes. Is this one of the two things? Everybody, are we multiplying or dividing by a negative number here? Are we multiplying or dividing by a negative? No, we are not, right? We are not multiplying or dividing by a negative. We were subtracting. We were not multiplying or dividing. So boom, that situation, nope. That doesn't fit. Number 2, did we swap the sides? Did I write x plus 4 over here and then 10 over here? No, I did not. I did not do that either. And so this is not a situation where we would flip sides or flip the inequality symbol. Are we starting to see where I'm coming from, everybody? Just understanding when and when not to do it. And it's going to take practice, but that's what I'm here for. I got your back every step of the way, my party people. So let's understand again, we keep the symbol pointed in the same direction. It didn't fall under those two circumstances. We didn't do that. And then lastly, everybody, what's 10 minus 4? That's going to be 6. And there we go. And there we go. And so the reason I subtracted from 10, so subtracted the 4 on both sides, is because the goal really is just getting the x by itself. The only thing that was with the x was that plus 4. So to get rid of it, all I had to do was subtract the 4. Again, the opposite operation that allowed me to cancel it out, getting me that x by itself. 10 minus 4 is 6, and we're good. And so in this case, again, we did not flip the symbol. We did not, because the only situations, like I said, are when you are multiplying, dividing by a negative. And then number 2, if we were to swap, like literally move this to the right side, move this to the left side, which we did not do. All we did was subtract both sides. That's all we did. So with that said, like I said, at the end of all 3 examples, I'll let you take a screenshot, but that was number 1. Let's take a look here at number 2. Everybody, really quick, before we get started, remember that a great way to think about solving equations is to think about what operations you are currently seeing so you know what the backwards or opposite operation is. So everybody, here's what I noticed. I have negative 2 with that x less than 8. What operation is happening between the negative 2 and the x? Even though we don't see the actual operation written out, what operation is there, everybody? When we have the negative 2 and the x stuck together like that, yeah, what we are observing is multiplication. What we are looking at. I'm not asking what we're going to do. I'm asking what are we seeing? What are we looking at? And here that's going to be multiplication. So with that said, remember, solving equations, it's the art of working backwards. What's the opposite of multiplying by negative 2? Yes, we are going to be dividing by negative 2. Exactly. So what that's going to look like right over here, we're going to divide by negative 2, divide by negative 2. And then from here, everybody, that's going to cancel out on that left side, leaving me with just x. And then we have 8 divided by negative 2. Everybody, 8 divided by 2, that's 4. But a positive divided by a negative gives me a what? Yeah, it gives me a negative. So that's going to be a negative 4 on the right side. Now let's ask ourselves that question again. Everybody, did we go through a situation where we are supposed to flip the inequality symbol? Did we go through a situation where we had to do that? Okay, I see a lot of people saying yes here now. Now, can you give me a reason why? Because again, I'm not that good at math. When you tell me something, you got to tell me why. So why is it that we have to flip it from less than to greater than? Why do we have to flip it? Correct. We divided by a negative. Exactly. We divided by a negative. Let me write this down over here. We divided by a negative. We divided by a negative on both sides. So we flip the symbol. Because remember, everybody, what does multiplying by a negative on both sides mean, or dividing both sides by a negative mean? It means that you're going to make the numbers opposites. So if it was positive, it goes negative, negative goes positive. When you essentially flip the signs, you flip the relationship. That's what happens. So because we fell through that rule, that situation, that circumstance, dividing by a negative on both sides, we flip that symbol. So who here is starting to have their eyes open to how this mechanically works? Who here is feeling just, again, slightly more confident that this is making more sense? And yes, even a little bit, yes, that's still progress. Remember, everybody, we cannot step up to the plate for the first time and expect to just start swinging dingers and home runs. Like, that's not going to happen. But what can happen is if you continue hanging on here and give it the time and the patience that I know you have, you'll make progress little by little by little. And the next thing you know, you'll have one of those big light bulb moments that we really look forward to. So I know we got this, but let's keep it moving forward so we can keep building that confidence up. So let's go ahead. And it can be this easy. It can be. It's just a matter of knowing the rules. So now let's go ahead and take a look here for x divided by 3 is less than or equal to 4. Everybody, let's take a moment here. Because I'm going to agree with Bianca. This one gives me the heebie-jeebies. It looks a little scary. So we have x fraction over 3 is less than or equal to 4. So my party people, what have I been saying before? What I have been saying is observe what operation is currently happening so you know how to work backwards. Everybody, what does a fraction mean? If we have x over 3, what operation is that? Or what are we looking at? I'm not asking you what we're going to do. I'm asking you, what are we looking at? If you have a fraction, that represents the operation, division. That represents division. And remember, solving equations and inequalities, we're gonna work backwards. So everybody, the opposite of dividing by 3, that is multiplying by 3. So booyah, that's what I'm gonna do. I'm gonna multiply by 3 on both sides. But then I got to check myself real quick. Everybody, am I supposed to flip the sign right here? Am I supposed to flip the inequality? Am I supposed to flip it? Okay, I'm seeing a lot of no's, a couple yeses. Those of you who are saying no, again, help me out because I'm really terrible at math. Treat me like I'm your friend who's trying to learn. Why am I not going to flip it? Daniela, excellent statement there. Daniela says, no, because we're not multiplying by a negative. That's simple. It's that simple. Yes, we're multiplying, but it's not multiplying both sides by a negative. And so with that said, we're not flipping it. We keep it the same. So we'll proceed to cancel out on the left, leaving me with x. 4 times 3 is 12, and it stays pointed in the same direction. We did not multiply or divide by a negative, so things stay the same. So with that, let me go ahead and take a step back. How are we feeling, my party people, with these first 3 examples? We still have 2 more to go on the next page, but how are we feeling so far about those nuances, when to flip the symbol or not? All right, so in the beginning of class, it was almost It was more than half of us that were fairly confused. Now I'm really happy to say that it looks like it's maybe 60% now that are feeling confident. So if you're part of the 40% that's still not quite feeling super confident, don't worry. Give yourself that time. Notice how it's happening for other people. You're running your own race. When it happens for you, it'll happen for you. But you got to keep that open mind and persevere a little more. You got this. So let's take a look at this next page here in 3, 2, and 1. So let's take a look at these ones here. So I understand that we may not be totally at this one yet. So I'm going to actually swap this one out with another problem. Don't worry. I'm not going to put you in a position to feel like you're being tortured. I got you. Let me go ahead and just go through this one here, and I'll give us the other example. So my party people, we have 7 is greater than or equal to x plus 1. So everybody, to get x by itself, we see that we are adding 1 to the x. So everybody, what's the opposite of adding 1? Yeah, you guys got it. You know that. Yep, subtract 1. Now, where are we subtracting 1? Correct. Thank you. Appreciate it. Both sides. So we're going to subtract 1 over here and subtract 1 over there. And once we do that, we can cancel that on the right side. And it's going to give us 6 is greater than or equal to x. Awesome. There we go. Boom. But remember, if we were looking at answer choices, the answer choices would have x on the left side, not the right side. So if I were to swap them, everybody, if I were to just take a moment and swap these two sides to write x on the left and 6 on the right, what do I have to do with that symbol? Yeah, we have to flip the symbol. Because again, if we swap the sides, we flip the relationship. You can't say that 6 is greater than or equal to x, swap the sides, and it's still greater than or equal to. That's not going to make sense. So if you swap the sides, you flip the symbol, going from greater than or equal to less than or equal to. And there we go. That's the other circumstance that we would apply that rule. Again, the first circumstance, multiplying or dividing by a negative. The second circumstance is just like we saw right here, if we swap the sides. So there we go. Who's ready for the next one? Type ready in the chat box and we'll get right to it. Sweet. So like I said, understanding where people are right now, I know that we want to focus more on the rules, the negatives, and the swapping. So I don't want to just throw this wrench inside of the machine here. It's just not going to be fair to everybody. So let me go ahead and just give us a different problem here. Let's go ahead and say that we have over here, let's say we're doing negative 3x is greater than, and then let's go ahead and say 15. So let's say we have negative 3x is greater than 15. Everybody, if we're trying to get x by itself, the operation that we're currently looking at is what? What are we currently looking at in terms of the operation? I see a negative 3, but what's the actual operation? It's multiplication. Yeah, it's negative 3 times x. So if I want to get rid of the negative 3, I got to do the opposite operation. And I would be, yep, that would be division. I would divide both sides by negative 3. And so with that, once we divide both sides by that negative 3, it'll cancel out on the left, giving us x on the left. 15 divided by negative 3, that's going to be a 5, but it'll be a negative 5 because a positive divided by a negative, remember, that'll always be negative. And so what's the last thing I need to remember in this situation? Yeah, we got to flip the sign. We have to flip the inequality symbol because we divided both sides by a negative. Again, it's only if we multiply or divide by a negative that we will flip in this circumstance. Not adding or subtracting a negative. No, that doesn't matter. It's if we multiply or divide by a negative. So with that said, booyah, that's going to flip over to less than, and this would be the proper answer. So with that, Deborah, I know we have some reservations about me not doing this one over here. I'm more than happy to just write out the solution for this one right over here. But trust that in the next lesson, the follow-up to this one, we're going to be doing plenty. Trust me, I have 15 problems just like this one written at the end of these slides. So what I'm trying to do is I'm trying to make sure I keep everybody's morale up because I don't want to skip too far ahead and do something that's way, way, way harder. So this is out of respect for the collective group. I want to make sure that everybody feels good about it. So I'll write out the solution right over here, but don't worry if this doesn't make sense. It's all good. I'm just going to write out the solution right here. The first step would be to add 3 to both sides. And once we do that, that'll cancel on the left, leaving us with 2x is greater than 10. The last step we'll take is dividing both sides by 2, a positive 2. So there's no flipping of the sign, no flipping at all. So it'll just turn into x is greater than 5. So it's very similar to solving a regular equation. And we just have to look out for those situations if we are multiplying or dividing by a negative, or if we are swapping both sides entirely, which none of those happened. And so that's the answer here. And again, if you didn't quite understand where all this was coming from, don't worry at all, my party people. We'll continue building our skills up to 2 and 3 step inequalities. I got you. So with that said, my party people, are we ready to start doing some multiple choice answers, some multiple choice questions? Good. All right, sounds good, everybody. Let's go ahead and turn that confusion to confidence. So here's how I want to try this out. I want to give y'all, and again, the majority of today's questions, maximum take 2 steps. So here's where I'm going to be reasonable with y'all. I'm going to be reasonable and give us 1 minute and 15 seconds per question. I promise you it's enough time because you're going to have the opportunity to look at the problem and say, okay, what do I see? What should I do? And then once you do it, then you want to ask yourself, okay, did I come across a situation where I have to flip the symbol? And that's it. So I know that we can definitely get this done in the minute 15 seconds. And if we feel like we get stuck or confused, don't worry. That's what I'm here for, to help us out. Are we ready? Good. I'm glad that we have that enthusiasm. There's a timer on the screen. Let me go ahead and work this down to 1 minute and 15 seconds. There we go. Let's go ahead and begin with this first question. Give it a shot, my party people. I'm really happy that we're continuing on with this. Y'all are doing amazing so far. Also, do not share your answers. Just type ready in the chat box. When you have an answer, just don't share it yet. And looking at our final 4, 3, 2, and 1. All right, let's give it a shot, my party people. I'm going to go ahead and leave the timer on the screen because we're going to move forward to the next question pretty soon. So let's zoom in here. Let's give it a shot. So everybody, what we are observing, what we are looking at is we see that we have x plus 2. And we're trying to get that x by itself. So with that said, my party people, well, the opposite of adding 2 is going to be subtracting 2. And we just have to do it to both sides. That's all we have to concern ourselves with, just following those rules. And so once we do that, booyah cancels out. And then we'll have x on the left. We'll have 3 on the right. Everybody, should we flip the inequality symbol? Should we flip it? No, we should not. Correct. And we're not going to do that because all we did was subtract 2 on both sides. So because it didn't fall under those two situations or circumstances, we don't do it. We just keep it as x is less than 3, making the correct final answer B right there. Cool. Who got this first one right? How are we feeling? Good. Sounds good. Let's keep working through these situations, again, with that faith that, again, if we make a mistake, we're covered, we're good. Here's the next one coming up. Let me get the timer back on the screen, and here's the next one. And 3, 2, 1. Let's give it a shot here. So we have x minus 3 is greater than 0. All right. Well, in this case, what we're observing is we are seeing 3 being subtracted from x. So to get x by itself, we're going to go ahead and do the opposite of subtracting 3, and that's going to be adding 3, again, to both sides. So once we do that, cancels out on the left, giving us x. And then on the right side, 0 plus 3, that'll be 3. And in this situation, everybody, do we flip the inequality symbol? Correct. We do not. We do not, because remember, the only two circumstances to flip. So to flip the symbol, one of two things. Number one, we have to either observe that we are multiplying or dividing by a negative, which when we take a look at what we've done, we did not do that. We added 3 to both sides. So therefore, that didn't fit the bill. The other situation is if we are swapping the sides entirely. Did we swap sides? No, we did not. We did not. We simply added 3 to both sides. That is not the same as quite literally doing this. If we had x minus 3 is greater than 0, if we swapped out or swapped the sides entirely, we would have x minus 3 on the right, 0 on the left, and we would flip the symbol like that. That's what swapping the sides looks like. So my party people, does that make a little more sense in terms of why we did not flip the inequality symbol in this circumstance? Sweet. I'm glad. Like, again, I'm definitely paying attention here in the chat box to those of us that are, again, just right there, opening that door to confidence. I'm definitely here for you. So with that, let's keep it moving. Let's keep working. Let's move into the next one with confidence that we will review it right after. Here's the timer in 3, 2, and 1. And I have a question here in the chat box from Catherine saying, how do we know if an operation is subtracting or if it's just a negative number? So Catherine, it's really going to be about looking at what's happening directly to the x. If a negative number is attached to the x, that's multiplication. If you have a negative number away from the x, that's actually subtraction. We treat that as subtraction. And so we'll continue going through examples. Keep a good eye out, and I'll keep doing the same in terms of pointing out the differences in those situations. I got you. Alrighty. And looking at our final 3, 2, and 1. Let's give this next one a shot here, my party people. So we have 4x is less than or equal to 12. All right, everybody. So answer this really quick. Because we are observing 4 attached to the x, what operation are we currently looking at? Yeah, we're currently looking at multiplication. So to do the opposite operation, we will divide both sides by 4. Right there and there, allowing us to cancel out the 4 on the left side. We just divided, so that's going to be a little concerning. But remember, if we divide by a negative on both sides, that's not what happened. We divided by a positive. So there's no flipping to be happened here. So nope, keep that the same, less than or equal to. But then 12 divided by 4 is 3. And there we go. The correct answer here will be A. X is less than or equal to 3. And so if we thought it was 48, that's probably because we just got it mixed up in terms of, oh, we see multiplication. I see a 4, I see a 12, bring those together and I get 48. But remember, it's about going through the proper order of things. We saw that we had multiplication, so we needed to do the opposite, which was divide by 4. All right, my party people? It's all good. And I don't want anybody in the chat box, alluding to criticizing somebody else for making a mistake that I think all of us would have made had we not had proper coaching. So let's go ahead and keep it positive here. We got this, and let's go on to the next question. Timer is going up in 3, 2, 1. Let's keep it up. There's the next one. And that is time, my party people. Time is up. Go ahead, put those answers in. What do we have? Okay, I see that confidence coming in. Let's go ahead and give it a shot here. Let's zoom on in. We have -2 multiplied by x is greater than or equal to 6. Okay, let's give it a shot here. So again, that question earlier, I remember seeing, I believe it was from Catherine. Let me know if that's correct. And I saw that we were asking, how do we know the difference between just subtraction and a negative, right? So in this case here, notice that we have -2, but it's attached to the x. So it's not subtracting 2, it's -2 multiplied to the x. Remember that solving equations and inequalities, it's all about what's happening respective or relative to the x. So in this case, -2 is attached to the x, so that's multiplication. So we'll do the opposite here and divide by that -2. Exactly. So we have -2 right there, divide by -2 over here. Now, should there be an alarm going off in my head to remember to do something, or should we just stay chill and not do anything at all? Yeah, we got to flip it. It falls under one of those circumstances, right? It falls under one of those circumstances, which is, hey, if we're multiplying or dividing by a negative. on both sides. -2, -2 on both sides. Yes, we will flip the sign. So instead of greater than or equal to, that's going to switch to less than or equal to. We cancel out on the left, so it's going to give us x. And then on the right side, 6 divided by 2, that's going to be 3, but then a positive divided by a negative, that's going to give us a negative. So the correct answer here, my party people, is x is less than or equal to -3. And the correct answer here is B. And there we are. So who here is, for the first time or second time now, looking at this saying, wow, this makes a lot more sense now. I can definitely see when to do these actions, when not to do these actions. This is actually pretty doable, right? So that's what happens when you go through the nuance, those details, the fundamentals. Because if all you're going to be expecting yourself to do is open up the book and do 10 random practice questions, close that book, come back the next day thinking like you just got a PhD, guys, it's not realistic. Because one, you're not grounding what you're doing in some paradigm or philosophy or, or some nuance. You're just doing things to go through the motions, hoping that something sticks. If you've ever heard the adage, throwing spaghetti at the wall, hoping something sticks, that's exactly what that is. What we're doing here is we're building confidence the right way. 3, 2, 1, next up. Let's get it done, everybody. And remember, do not share those answers until time is up. And that is time, my party people. Go ahead, put those answers in, and let's get to work. So I can go ahead and empathize with us right over here. When we take a look at fractions, I can agree with you if you say that, man, looking at fractions, it's not the funnest thing to look at in the world. So who here feels the same way? Who here feels like, yeah, the fraction is really what messed me up more than anything else? Gotcha. So remember, my party people, we have got to make sure that we address those fundamental issues. If we know we're having issues with fractions, negatives, decimals, whatever it may be, remember, my party people, we have got to make it a point to practice those fundamentals. For those of you who are watching this video live or in the recording, you know that you're in the program and you know where to go to get things done. So that's all I'll say about that. But here, we have a fraction. We have x on the top. Remember that fractions are division. Fractions are division. This being divided by that. My party people, what's the opposite of division? Hit me in the chat box. Correct, multiplication. So let's go ahead here and multiply. We are dividing by 5 is what we see. So to get rid of it, we will multiply by 5. So with that said, we'll have the x by itself after these cancel. Now I got a big question here. Because, my party people, I multiplied, should I flip the sign from less than to greater than? Should I flip it? Well, why not? I see all of y'all drowning the chat box with no's. Why not? Again, I'm bad at math. Help me out. I'm not that confident. Why not? What's not negative? What's not negative? The 5 being positive or negative is not the problem. There we go. That's what I was looking for. Who said that? Let me scroll back up. There we go. Andy, thank you. Excellent response. It's because we did not multiply by a negative. Remember, multiplying or dividing by a negative on both sides is what will trigger the flip. So with that said, no, we are just multiplying by a positive 5 on both sides. And so because we are not multiplying by a negative, then we're good. It stays the same. It stays as less than negative 1 times 5. 1 times 5 is 5. Negative times a positive is a negative. And so the answer here is x is less than negative 5. And that's going to be answer choice D. So with that said, my party people, for those of us that were slightly confused on just, the flipping, why didn't we flip here? Do we see why in this case? Sweet. And again, mistakes are going to happen, but that's the advantage we have, making the mistakes here so we don't make them on the test. Next up in 3, 2, and 1. Let's keep it going, everybody. And looking at our final 2, 1, and time, my party people. Go ahead, put those answers in. What do we got? All righty. So let's go ahead and give this one a shot here. So this one is going to be slightly tougher. Now, let's check things out here, everybody. First thing that we want to observe is, where's the x? Okay, I see it right there. Now, what's in the way of us just getting x by itself? Well, there's a negative in front of the x. And also, we're adding 3 to whatever this is. So let's take it one step at a time. One step at a time. So the first thing we're going to want to do is get rid of what's furthest away from the x. That's typically going to indicate the last operation to take care of. So in this case, we have plus 3. Opposite of adding 3, Angelique, correct. We are going to be subtracting 3 on both sides right there. So now that we've subtracted 3 on both sides, let's cancel out right there. And we're going to have negative x less than 3. Notice it stays less than because we just subtracted 3 on both sides. We did not multiply or divide by a negative. So boom, there we have that part. But we're not totally done. Our answer choices have x by itself. What we have over here is negative x. So with that said, everybody, we have got to do something to both sides still. And to do that, I'll just go ahead and say, man, let's multiply both sides by negative 1. Just multiply by negative 1. Because if I multiply both sides by negative 1, everybody, a negative times a negative, that's going to give me what? Yeah, that's going to give me positive. A negative times a negative, that's going to give me positive. So that's why that's good right there, because it's going to cancel that out. And then we're going to have 3 times negative 1 on the right side, giving me negative 3. Now, my party people, what should I do with that symbol? Yes, we have to flip it. Because notice we multiply both sides by negative 1. And so because we multiplied by a negative on both sides, we will change it from less than to greater than, and there is our answer. X is greater than negative 3. So there, with that said, the correct answer here is C. And there we go. Sweet. So who, because I know this one was probably the toughest one yet, who's feeling pretty good about understanding any potential mistake you might have made on this one? Good. And I see a question here from Bianca. I got you, Bianca. Great question. So the question from Bianca is, Coach, why didn't you divide it? Why did you choose to multiply? I've never really seen it done this way. It's interesting. So both ways work, Bianca. Both ways work. Because in the end, the same result is achieved. We could multiply both sides by a negative. We could divide both sides by a negative. Both, the outcome of both is that you're changing the signs of both sides. That's really what's happening. So you can choose to divide both sides by -1 if you wanted to, or you could multiply both sides by -1, because remember, multiplying and dividing by 1, you stay at the same exact number. It's the negative that makes the difference, and you can multiply or divide by a negative. It'll change the sign anyway. So let me know if that makes a little more sense, everybody. Yeah, that's going to be just with the -1, correct. You can multiply or divide by -1. Both ways will work. Yeah, great question. Great question. So let's keep up the great work, everybody. Let's keep it going here. Timer is up. And 3, 2, 1. Let's keep it up. You got this, everybody. All right, my party people, that's time. Let's go ahead and give this next one a shot. So, who was a little nervous about this one? Who was a little unsure of themselves on this one specifically? Yeah, this one's a little different, right? Because we got the variable here on the right side, not the left. It's not the safe way of looking at it. So I got you. Let's go ahead and go through it one step at a time here. I really got you. So step 1. First, before we decide to flip, to be honest, you can flip this right now if you wanted to. And I'm going to actually show you how in the end, you'll still get the same correct answer. Whether you want to flip it now, so I'm going to write this in blue over here, x minus 1, and then on the right side we have 2. So remind me, everybody, if I chose to do that, if I chose to swap the sides, what do I have to do with that symbol? Right, we can flip it. So it goes from greater than to less than. So we can choose to do that if we want to. So hang on to this thought over here. I'm going to start from over here, though. I'm going to solve it from this, and I'll show you that if we chose to swap the sides, we can still get the same correct answer. So everybody, let's focus our attention over here. If we focus our attention over here, we have x minus 1. Everybody, what should I do to both sides to get rid of that minus 1? Correct. Opposite operation. We see subtraction of 1, we'll do the opposite, and we will add 1. So we have plus 1, and from there, my party people, we'll have 2 plus 1 is 3, greater than x, right? And so because of that, we didn't have to swap the sign, the symbol. Nope, we didn't. All we did was add 1 to both sides. However, when we take a look at our answer choices, the x is on the left. The x is on the left. So at this point, yes, it would be intelligent here to go ahead and swap the sides. I'll move the x over here. I'll move the 3 over there, giving me x and then 3. And then because of that, I will flip the inequality symbol. It falls under one of those circumstances. And so, boom, greater than turns into less than. And so that's one way to get the answer. I can show you the other way right over here. So when we check out the other way, after we swapped them, notice that we flipped the symbol like we were supposed to. Again, 2 goes on the right, x minus 1 goes on the left. We did that. Greater than turns into less than. So once we have that, we'll go ahead and solve. It's just like we did before. We have plus 1 on both sides. And once we do that, booyah, we're good. We have x by itself after canceling out. And then we have 2 plus 1, which is 3, keeping that less than symbol. And notice how the answer is still the same. Same answer both ways. My party people, are we good on that? Does that make sense to you? Right on, my party people? Right on. So with that said, my party people, we are good on that. Let's keep the party going. Let me get the timer here up on the screen. Man, time has flown in this class. This is great. So let's go ahead and keep the party going here in 3, 2, 1. Let's go. Try this next one out, and we'll be back in another minute here. Keep up the great work, everybody. You're doing great. And that is time, my party people. Go ahead, put those answers in. What do you have? What do we have, everybody? Is this a perfect question? Is this a perfect question? Imperfectly perfect. So this is one of those questions where we're going to take a mistake by me and we're going to turn it into confidence for you. So who here, when they were solving this, your confidence was way up there and you were like, hey, hold on, there's something wrong with this. Well, guess what? That's a very good sign. That's a very good sign. Well, I do apologize for the little typo here because it's going to happen every now and then. We can definitely turn it into confidence because y'all understood very well that, hey, I know what I'm supposed to be doing. I know that if I'm looking at this minus 3, x minus 3, I know for a fact that, hey, I'm supposed to be adding 3 on both sides, on the right, on the left. And once you do that, cancels out on the right. You're just going business as usual. And then you notice that, hey, 7 plus 3, that's going to be 10. Keep that symbol because we didn't multiply or divide by a negative. And then we have the x right there. And so then from there, my party people, from there, what do we have to do to get the x on the left side? Yeah, we got to flip. If we swap the sides, we flip the symbol. Exactly. So with that, boom, bam. And so we have X on the left, 10 on the right, and then we flip the symbol. So the answer here is X is greater than or equal to 10. And then go ahead, take a second. Go ahead and laugh at me in the chat box, because again, the typo is going to happen. And when they do, I want you to take full advantage of making a clown out of me. You know, I don't trip often, but when I do, I'm going to fall on the pie. Yeah, so, yep, again, thanks for being patient on that. A, B, C, and D here. And correct answers. Nah, I'm kidding. You know I'm going to take it like a champ. Mistakes are going to happen, and I do apologize for showing you a mistake here. But I'm glad that most of us here were looking at this saying, yeah, coach, this was wrong. Notice how most times you might find that we have to wait until we're halfway through to actually have the confidence to say it. But the fact that y'all are saying and pointing out mistakes while we're learning this, that shows a very good sign on your behalf. So nice job picking that up. I do apologize for the typo. Now let's go ahead and keep it going to the next question. Here we are in 3. There we go. 3, 2, and 1. Let's keep it up, everybody. All right, my party people looking at that final 5. And 2, 1, and time. So go ahead, put those answers in. Everybody, what do we have in this problem here? And I saw the comment there. Appreciate the comment. But you are not allowed to call me an amazing teacher until you pass. So with that said, let's go ahead and try this one out here. We have 4 is less than or equal to X plus 2. Okay, so let's handle this like champs. Here we go. We want to get that X by itself. So we have 2 being added onto the X. So just like Angelique said, we're going to be subtracting 2 from both sides. So we have minus 2, minus 2. And we'll write that right there. Cancels out on the right side, giving us 2 is less than or equal to X. And so just like we had earlier, hey, we got to get that X on the left side. We want to get that X on the left side. And so with that, what we're going to want to do is swap those sides. So I'll go ahead and move the 2 to the right side, move the X on the left. And everybody, what are we doing? Once we swap the sides, yeah, we flip the signs. And so with that, we have the less than or equal to that will turn into greater than or equal to, making the correct answer here, my party people. Answer choice B. And there we go. What did we go through? That was a straight up, how many questions was that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 total questions in today's class, counting the examples that we did in the beginning. And look at how, just take a moment to take inventory of how you personally feel about handling inequalities. Because for those of you who have taken practice tests, this right here, while this may seem simple now, I think we can all agree that problems like this have shown up on our practice tests on the real deal, where just knowing that swapping the sides flips the symbol, knowing that multiplying and dividing by negatives makes it flip the symbol as well. right? So isn't it amazing what you can do when you learn some of these rules that are part of the greater test, right? When you learn these rules and not just learn them and memorize them, but actually apply them and understand them. Notice where your confidence is at. Notice how before class started, we'd be looking at questions like this and say, Coach, I don't want to do this. I would rather go to Lowe's, get a cardboard cutout of you and make some holes, right? But now we're looking at this and we're saying, hey, if we saw this in the test, I would actually welcome that because that's easy points now. And that's the process that we go through while we study. One day better, one day at a time, making something that's challenging yesterday easy today. And it happens with that methodology. One day better, one day at a time, my party people. And so with that said, who's excited for the follow-up session tomorrow?